Welcome back, students. In this video, we're going to do a few examples related to our quantum numbers from our quantum number lesson that we did in the previous video. So we'll work through the examples that are found in your notes here. We're just going to really try to interpret what the questions mean, what they're asking, and how we can use our knowledge of quantum numbers to answer them. And then you can go and do some practice problems in your worksheets and in the practice visuals, as well as the practice Brightspace quiz. So here we have, if a scientist is studying the third shell of an atom, which orbitals exist there? Let's look at that question and really dig deep into what the question is really saying. We're saying the third shell of an atom. So what that means is we are in energy level 3, which is our principal quantum number 3. And we want to know what type of orbitals exist there. So to know the types of orbitals that exist there, you need to know the subshells. You need to know, like, is there S, P, D, F, so on and so forth. So how do we figure that out? Well, we need to go and figure out what the L values are at shell level 3. So L values can be, remember that's from 0 all the way up to n minus 1. So we can go 0, 1, and 2. So what this means is that at energy level 3, there are sublevels S, P, and D. So if there are sublevels S, P, and D, it means there are S, P, and D orbitals. That's what that means. So we can say that, therefore, the orbitals in the third shell are S, P, and D. But I'm going to be more specific. I'm going to specifically say they are 3S, 3P, and 3D. The 3 will indicate that they are the orbitals S, P, and D in energy level 3. Because don't forget, you could also have these in energy level 4, and they'd be 4S, 4P, and 4D. So I'm just being more specific there. The types of orbitals are S, P, and D. They're found in the S, P, and D sublevels. And I could only figure that out by knowing what sublevels are there. So I had to find my L value, which I could find from my principal energy level over here, which was energy level 3, told by the question third shell. Let's try question number 2. You can try it yourself first. Pause the video, try it yourself, then continue playing it to check your work to see if you're on the right track, and you can get some immediate feedback that way. If I am studying the electrons in the 5p subshell, what are their quantum numbers? So let's go take a look at what the question is saying. The question is saying the 5p subshell. So that gives us actually a lot of information. That tells us what energy level we're in. We are in energy level n is equal to 5. Great. Another interesting thing that tells us is we are in P. That tells us our L level right away. We don't have to guess. We don't have to write L is equal to 0, 1, 2, 3, 4. We are told it's P. If you're in P, you are in L is equal to 1. Now, we're not given more information, so the ML values, we have to write all of them that are possible for L is equal to 1. So -1, 0, +1, because remember, ML is a range from -L all the way to +L, including 0. And then don't forget, we are not told the specific electron, so we have to write all the possibilities for MS as well. And for all electrons is simply plus or minus half. And so this would be the quantum numbers for electrons found in a 5p subshell. If they gave me more information, like if they said in the first box, in the first orbital of the 5p subshell, then I could have maybe said ML is -1 specifically. And if they said it's an electron that has an up spin, I could have said then plus half. But because they didn't give me more information, the only two numbers I was really certain of were the n is equal to 5 from the 5 in the 5p, and then the L is equal to 1 from the p in the 5p. Everything else had to list all the possibilities there because they didn't tell me more information. Let's try our next question. We'll try question 3. And before I attempt it, maybe you can try it yourself, pause it, and double check your work. So it says here, which orbital is indicated by the following quantum numbers? So we want to know essentially what sublevel we're in. By the way, when you have your ML values, you should indicate them with their charges as well, their signs, like positive or negative. So we want to know what orbital we're in. So we need to know what sublevel we're in. So really, when it comes to this, we need to look at the L value. So what orbital are we in here? We are in the L value 2, which is D. And what that means is I'm in the D orbital. Now I want to be specific. I'm in a D orbital found within the third shell. How do I know that? Because of the n is equal to 3. Next one. L is equal to 1. That means I'm in a P sublevel orbital. And specifically, I'm in a P orbital from the 4th energy level. Just to be clear, this entire case here is the P sub level, and an individual one is a P orbital in the P sublevel. And this particular P orbital I'm dealing with right now is in the 4th energy level, and this one's in the 3rd energy level for the D. So next we'll go try question number 4. For question number 4, we have to find the error in the quantum numbers. We'll start with A. As usual, pause the video, try it yourself, then you can check the answers. So we have n is equal to 2, and L is equal to 1, ML is equal to negative 2, MS is equal to positive or negative 1/2. My MS looks okay. I usually look at that because if there's a different number than half, then that's a mistake. It should be half plus or minus. So let's look at our n value. Our n value is 2. If our n value is 2, our L value could be 0, and it also could be 1. So that seems okay so far. Let's look at our ML. I think the problem's probably in here because everything else looks good. If you have ML, this number here is negative 2. That looks like it's outside of our range. Remember, if you have L is equal to 1, ML has to be negative L to positive L. So if L is equal to 1, then ML must be either negative 1, 0, or positive 1. We have to change the negative 2 number to 1. So that's our error. So the error, let's do this. So error is ML. And to fix it, we need to change the ML to one of these values here. Okay. I just want to be clear though. Some students will sometimes say, well, okay, yeah, I see that. But could I also fix it by changing the L value? So for example, they'll say, could I say n is equal to 2, L is equal to 2, ML is equal to negative 2, and then MS is equal to plus minus half. So they'll say, look, I fixed it. Now the ML and the L are okay, like they're in the right range. But what the student didn't realize is that, look, by doing that, now you made another mistake. The n is equal to 2 was fine before because you can go to 0 up to n minus 1. But now the n and the L won't match here. So then you have to go and change that as well. So really you just need to change the ML value to match its L. If you do change something else, just make sure there's no other ramifications that you may have done. There's no other ramifications to that change. So just be very careful when you're doing that, and you'll get the hang of it as you practice. Let's do the last one here together. So once again, I'll check my MS. Looks good. Plus minus half. N is equal to 1. Okay. So, I mean, that's fine. We'll start there. L is equal to 1. I think there's a problem there because you'll notice that if n is equal to 1, L can only go from 0 up to n minus 1, and this is too high. So the error is L is equal to 1. The fix, we have to change the L to 0, right? So the fix is if n is equal to 1, then L can only be 0, right? That's our fix. And now the problem here, though, is we need to continue this. So some students, and I think I chose a fix that causes a problem here. So if I change this to L is equal to 0, my ML can't be 1 anymore. Okay? Therefore, ML must become 0 as well, right? Because it's no longer in the range. So if I did that fix, this needs to become 0 as well. Okay? An easier fix, if I had taken some time to look at this carefully, would have simply been, so a better fix, I would have still accepted this if you did both those changes. That would have been fine. But a better fix here, so you're not changing too much, try to do a fix, just a one-time fix. So let's say if you take 2 fixes, that's a level 3. If you do a 1 fix approach, that's a level 2. Or a level, not a level 2, sorry. You wouldn't want a level 2. You'd want a level 4. So that's level 4. So let me retry this with a 1 fix approach here. So a better fix would be if L is equal to 1, then N is equal to 2, let's just say. So now it makes sense because N is equal to 2. L can actually be 1. ML can be, let's make the sign +1, +1. And then your MS can be plus or minus half. So that there's a 1 fix level 4 issue there. Students sometimes ask, could this have also been N is equal to 3 or 4? Yes, it could have been, because this L p orbital or p sublevel exists, from 2 onwards. So you could have put a different n value altogether. Anything higher than 1 would be fine. That would work out as well. So that's another approach that you could have done, and that would have been acceptable. So a 1 level fix works best. If you do another fix and it causes another problem, just always rewrite out the quantum numbers to make sure that there's no other problems created by the fix you did. Best fixes are the ones that can be done in 1 step. So if you're able to do all these questions, then you're ready to try the questions in the visuals, in the worksheets, and then the practice quiz.